Hello guys and welcome back. So yeah, let's move on to add some more stuff to this guy. So I think one thing we need to do and we could do is kind of like adding some edge variations because they're kind of like perfect for now. So let's do that. We're going to go for a for each primitive. For every individual primitive, we can check on the single pass to take a look at that. Yeah, for every individual one, we kind of wanted to give it some more subdivision and then move the points around. Okay. This could be actually a full stream doing all sorts of stuff actually. So we're gonna go for like, first of all, a divide. And again, we're not gonna do convex polygon, but break polygons. Breaker polygon size will be 0.1. Actually, that's gonna be on the other direction now, because we wanted to cut across it. So maybe 0.1 in here. Okay. All right. And then we could also offset it if you wanted to cut it from the center. But I think that it's fun. It's fun to have a little thing in here, I guess. All right. So what we do is moving those things inwards. Okay, we only want to move those things inwards. So I kind of wanted to calculate like a direction. Okay, and that direction is fairly easy to calculate. We can first of all get a direction from center. Let's do the center, which is gonna be get bbox center of our current input minus the position of the point. Okay. And we can just say this is going to be our normal. So at normal will be equals to that. Okay, now let's check that. You can see the normal of the points are doing that. Okay, which is not exactly what I want. I wanted them to be only moving on the x direction. So at normal dot z will be equals to 0. Okay, now we're getting this direction of normal. It's just facing inwards. Okay, which is pretty cool. And then all we have to do is just moving them inwards in a random way. Okay, we can call this guy add edge random. And then we can say add position plus equals add normal times like a random value based on point number plus the current iteration, which is something we don't have. So let's go ahead and create a meta node. That can actually just go connect to our Rango node, so we can ask for the detail of the second input and then iteration 0. Okay. Okay. All right. Now you can see we're moving them inwards like that. Now, of course, we don't want to move that much, so we also multiply that by a channel called offset amount. Okay, so that way we can define like or determine how much we're offsetting it. This can also be driven by a noise sometimes. Okay, all right. Now we of course move this guy to our controller. Okay, so drag this guy over. We can call this guy edge variation multiplier, apply and accept. Okay, so we can do that. Because they're all moving in, so there will be only gap but no overlapping when you're done with all these. So let's take a look at that. Right, so everyone is only going in, which is exactly where we want to go, right? Otherwise it's gonna overlap, which is not nice. And I only need just a little bit, right? This is not gonna be something way too broken in this case. All right, and while we're at it, we can do other things, like we can tilt them differently, right? We can also give them thickness and stuff. Oh, one more thing. Here we can also say at p dot y plus equals to a random number also. Okay, so to fit 0, 1, from a random value at point number plus this detail thing we're doing earlier with iteration, and then we just add another number, and then we say a channel up down variation, negative to positive. Alright, we'll run this. Now we can also have some up and down variations. Okay. Okay, we can also drag that over to our interface. Call this guy height variation. Surface height variation would be better, because I also wanted to have variation for individual planks, so that's gonna be a different value in this case. So apply and accept. So now our interface is getting way too big, but yeah, we can add now variation like this. I think this is too sensitive, so I'm gonna go here and say U has to be in here. U are ranging from 0 to 0.1. Yeah, that's already too much. Cool. Alright, so now they're all having like this wavy up and down variations. Also wanted to keep them to the minimal. Okay, and also real up and down variations for every individual plank. It's going to be a little transformation node. Okay, for the translation Y, again, this will be a random value here. So I'm going to say, let's Alt E to open the editor here. Say it's going to be a random value, and fit 01 first. Random value of, I think it's actually better to already set up our height variation attribute. Okay. Copy parameter. Here, it's going to be fitting from the random to, you know, oh, we cannot paste relevant reference here, so we can ask for it right away by typing in. Height variation, of course, from negative to positive. Okay, and the random will be based on the current iteration, so we get that right away. So this is going to be the detail attribute of, come on, don't crash. Okay, detail attribute of da, and then, oh, what is the name of this? Oh, let's name this guy. This is going to be a variation. I want to do UV here also, actually, and extrude. Doing too much in one thing. Alright, copy that. And put this guy in here also. Metadata. And put this guy in here. Okay, that way, meta is fine. Don't need to have data in there. Just keep my code shorter. Okay, so ask for this guy's variation or iteration, and then 0. All right, then go ahead and accept that. Cool. Oh, getting arrows. Let's see what does it say. Syntax error for this. Interesting. Let's see what could be the syntax error. Random detail of that. Okay, those are all good. Negative. Okay, that's weird. I don't really see the problem, but maybe it's in here, I just don't see. Because this is really long. That's why I don't like to put in things like that. It's kind of like problematic sometimes. So let's see, we can calculate that for every primitive first before we use it. So we can say attribute wrangle here, because it just feels like really don't like this method, but you know, sometimes it's convenient. We can say for every primitive, right, we got a random number. Okay, calculate random offset. Okay, we can say float height variation will be equals to channel height variation. Okay, run this. We copy parameter and paste it in here. Oh. Okay, have that. And then we just get this one into like float random will be equals to a random value from our prim number. Oh, actually, it's only going to be one primitive, so it's fine. We can just ask for the detail attribute of our second input iteration, and then 0, right? And then we fit that 0, 1 to height var. And negative to positive. Okay, make it a float attribute. Okay, oh, got the arrow again for some reason. Oh, that's why. Well, that's why I cannot really do that. Otherwise, in here I have to have the backtick float. Int actually. Current iter will be equals to that. We have done this before. Right? We had the problem before. It's like this language. This language is having some inconsistencies, in my opinion. Anyway, so yeah, we got this random value now, which is on the here. It's actually on every individual primitive, but it's fun. It's fun. So we just need to ask for the first one in the translation. So what we can do is now we can just ask for primitive of the operator input pass of this node. First input, it's primitive 0 attribute called random height, and then the first index. Okay, so that way we're basically offsetting it based on that. Okay, so it's a little bit different this time, and we see everything. You can see now everything is having a random height. This is too high though. Okay, so I guess this value is too sensitive, so we go ahead and tweak it. So from 0 to 0.2, I think that's probably the maximum I would go for. And that's already really big. Has to be something really subtle in this case. Right? Yeah, so that's quite a lot of variations we add to this. Right? Let's turn off the visibility of the lines so we can see the planks. Hit D button, go to the grade, and we can disable the grade. Don't see the background, so dark background. That way we can see what's going on. Right? Pretty cool, right? So now we have a lot of variation already with this deleting, with edge variation, surface height variation kind of thing. Alright, so yeah, let's move on to the next video where we can try to add maybe rotation variations, extrude out the thickness, adding UVs kind of thing. Okay, see you next time.